Okay, folks, it's time for the next edition of Make Electronics, where we go through all the experiments in this book and its successor, Make More Electronics. So we are now on to experiment number 7. Here we go. Investigating a relay. Ooh, nifty. I'm being sarcastic. Okay, relays are pretty much in a lot of our stuff. They're kind of like a transistor, but, bigger. Your cars, your washing machine, your oven and stuff, they're going to have them. So anyway, for this experiment, we're going to need our trusty 9-volt battery, which we're fully aware of. There we go. If you haven't seen a 9-volt battery before, I'd like to know what rock you're living under. Okay, so we're going to need some relays, which I will show you here in a minute. We're going to need a tactile switch. That's the switch that is clicky. We're going to need our normal test leads, obviously, as previous. I'm doing this so this is a little clearer for film, but you'll need whatever your flavor of test leads are. Utility knife and a multimeter. So I'm using this. You'll find out here in a minute because we're going to open up a relay. Okay, figure 7.1. Let's bring over our contraption. Ooh, there we go. So this is figure 7.1. So we're going to put our meter onto continuity. So for my meter, when I put on continuity and I press the function, it will beep. So here's figure 7.1. I have a 9-volt relay. Obviously, there are tons of different kinds out there. Mine just happened to be orange. And here's your clicky switch. So I got it hooked up as per figure 7.1. Pretty straightforward. And watch. I haven't hooked up the battery, but you can hear the clicky. So let's hook up the battery. Okay, so one thing I did do differently than the book on here is that, let me zoom out. No, wrong way. Is I did add an LED to it because, well, yeah, that just made a lot of sense to me. So watch what happens when I press the button. My meter gets continuity. I'm closing the circuit. And thus, my LED turns on. That's pretty straightforward. Basically, you're creating this is an electromagnetic switch. When current is passed through it, it closes, current can flow through, and voila, we have a light. But, as you can see through the thing, what is on the inside of a relay? Now, the book, as you can see in, figure 7.6 and 7.7, it definitely doesn't recommend to do these. But, you really think those warnings are going to stop me? Let's go out in the garage and do something stupid. Okay, I'm out in the workshop because I'm not stupid enough to do this inside. Now, the book suggests that I don't do this. So that's pretty much as good as putting a big old circle around and saying, go do this right now. So that's what we're going to do. I have 3 relays that I don't mind parting with. We're going to use a chisel and try to cut it in half. We're going to apply some fire. And we got one more thing coming up at the end. I'll show you when we get there. The book doesn't go into it, but yeah, it's pretty cool too. So I'm going to put some protective stuff on because, well, I like my eyes and I like my lungs. Sledgehammer. Oh, actually that wasn't as bad as I thought it was going to be. I figured it wouldn't go all the way through, but I didn't ruin my chisel. Although, I really don't like this chisel because it's got the side blade, and I end up cutting myself on it because I'm a dummy. But, okay, let's try some fire. As you can see, pretty toasty. And boy, does this thing smell. So yeah, this is going to go in the trash and not into my pile of sacrifices. So, or maybe I'll put it in a bag. I don't know. So anyway, on to the surprise one. Our last little unsafe activity is I'm just going to use this benchtop grinder to grind the side off. And this works pretty good, but we'll find out here in a minute. Safety protection. Wow, that's not exactly what I thought it was going to do, but it's pretty cool. So yeah, we'll go back upstairs now and I'll take this apart with an X-Acto knife. I'm glad relays like this are cheap. Okay, well, as you can see, that was quite interesting. I don't know really what I was expecting, but I know I said I was going to throw it out, but keep in this container. Here's our, can't you see? Here's our burnt one. Crispy. And here's the one that I took the chisel to. I'm sorry, woodworkers out there. Please forgive me. And here's the one that I took the benchtop grinder to. I'm not sure what I was expecting. I should have did it from the side. But anyway, there's our sacrifices. These will go into the bin, which eventually I'll make some epoxy art out of this stuff. But that's probably a 2026 project. So off to the side. Back to our regularly scheduled programming, which now we're going to, I'm going to turn this off. Okay, so as I was saying, this is the same circuit as previously, as our orange one, except I'm using a blue relay. This blue relay happens to be 5 volts, so it will work at 9 volts, but I want to do it right, so I have this LM7805 that converts 9 volts to 5 volts. So you can pretty much ignore everything over here. I also included the LED. So as you can see, when I press the E button, green flag. Okay, but you're asking, why'd I do that? That's kind of boring. Just move that up there and watch. I took the cover off. That's why I have this. This is just my, craft night kit. You can get it on Amazon. Link in the description. What a surprise! I plug something. Things are expensive. Help me, I'm poor. But anyway, this is the relay. Top view. As you can see, it moves when I press the button. There is a mechanical function going on. Let's see if I can zoom in even further. That's pretty much it. I wish I had a high-speed camera. and probably showing you a little easier, but it's actually a pretty cool thing when you think about it. So anyway, that's all for this episode of Make Electronics. Experiment number 7, investigating a relay. Stay tuned for the next experiment. Please subscribe. And bearing anything else, stay sleepy, my friends.